Okay, good afternoon. Now I will go through page 28 and 29 of the Chem Bonding lecture. Okay, please turn to page 28 of your Chem Bonding lecture book. Okay, we have here 3 molecules and I'm going to demonstrate how we will describe the shape using the VS-EPR theory. Okay, we start off with SF6. Okay, we have this molecule here. We have already learned how to draw the structure and the dot cross diagram, so I will not go through that. Okay, sulfur has 6 electron pairs. Around sulfur there are 6 electron pairs and all are bond pairs and there's no lone pair. Okay, and according to VS-EPR theory, to minimize repulsion and to maximize stabilities, the 6 electron pairs are directed to the corners of a octahedron. Okay, so this is like the basic shape that we have learned, an octahedral. Okay, and the bond angle is 90 degrees and the actual shape we call it octahedral shape. Okay, so what are the things to take note of when we describe the shape? Okay, you need to show how many bond pairs and lone pair there are around the center atom. Okay, name the center atom. Then after that, this statement is not that important, but it's important for you to process, for you to think that, to consider how many electron pairs are there in total and what is the basic shape. Okay, and then since there's no lone pair, therefore the octahedron is the basic shape, octahedral, and the bond angle is 90 degrees. Okay, let's look at another molecule with lone pair. Okay, we have here PCl3. PCl3 has 1 lone pair and 3 bond pairs. Okay, around the center atom P. Alright, and to minimize repulsion, okay, the 4 electron pairs will be spread out to the corners of okay, remember what is the basic shape for 4 electron pairs? It's called a tetrahedral, right? So we will call this basic shape a tetrahedron. Okay, but because of the lone pair, okay, this lone pair will create a repulsion, okay, which is different from a bond pair repulsion. So this lone pair bond pair repulsion is stronger than a bond pair repulsion. Therefore, this angle here will be smaller than the usual 109.5. So in this case, it will be a 107 degree. Okay, and this shape we call it a trigonal pyramidal. Okay, so the things that I highlight are the important things that you need to write down in answering exam when you're asked to describe the shape using VS-EPR. Okay. Moving on to the next molecule, H2O. Okay, H2O is something that you're familiar with. Okay, H2O has 2 lone pairs and 2 bond pairs. Okay, surrounding the oxygen atom. And to minimize repulsion, to maximize stability, okay, the total number of electron pairs is 4. They will be directed to the corner of a tetrahedron. Okay, but in this case, I have 2 lone pairs and 2 bond pairs. So I will mention that there's a lone pair repulsion. There's also a bond pair repulsion. Okay, and the lone pair repulsion is stronger than the lone pair bond pair repulsion, and is stronger than the bond pair repulsion. Okay, therefore, this angle here will be definitely smaller than the 109.5 and it will also be smaller than the 107. In this case, it's a 104.5 degree. Okay, and it takes up a band shape. Okay, so you see that the basic shape is that of a 4 bond pair, which is a tetrahedron. Okay, but the two lone pair are considered invisible. So it has two bond pair. These two bond pair forms the band shape. And the angle between these two bond pair is less than 109.5 and is less than 107 because of the lone pair repulsion. So this bond angle is even smaller, it's 104.5. Okay, so we have considered the three molecules and we have considered how we can describe the shape using VSEPR. Okay, now I'm going to extend it to consider why two molecules of similar shape but yet they have different bond angles. Okay, these two molecules are your H2O and H2S. Okay, they have the same shape because sulfur and oxygen are in the same group, just that they are of different periods. Okay, as you can see here, the bond angles are different. In water is 104.5 or 105. In H2S, the bond angle is much smaller, 92 degrees. Okay, why do they have different bond angles? Okay, the reason is due to the electronegativity of the atom O and atom S. O is more electronegative. Okay, so therefore, the oxygen draws the bond pair closer to itself than the S, and that creates greater repulsion. Okay, if I were to draw it, this is what it means. Okay, the bond pair of HO is drawn closer to the O, and the bond pair in HS is further away. So I'm drawing something that's exaggerated, but as you can see, if the bond pair are closer, there's a greater repulsion, so the bond angle will be greater. If the bond pair are further away from the center atom, the bond angle is smaller. Okay, so take note of this. Electronegativity of the center atom affects the bond angle in these two structures which have similar shape. Okay, so the reason is because of the electronegativity. Okay, another special case. Okay, why certain species exist and not others? Okay, this is a concept of the ability of period 3 onwards element to expand or attack. Okay, we have two examples here. One is a sulfur hexafluoride, which is SF6, and oxygen hexafluoride does not exist, OF6. Okay, if we were to draw SF6, it looks like this, SF, okay, which we have seen just now in the first example. Okay, we can draw it out. But if we were to change this center atom to oxygen, alright, there's no such structure. Why? Okay, if we were to draw the structure and to count the number of electrons, we will have a problem. The number of electrons surrounding oxygen is 2, 4, 6, 8, 10, 12. 12 electrons, which is not possible because oxygen, which is a period 2 element, does not have vacant and energetically accessible to expand or attack. Therefore, OF6 does not exist, but SF6 does. Okay, so this is a concept of the ability of period 3 onwards element to expand or attack, and period 2 element not to be able to. Okay, this energetically accessible and vacant orbital means that okay, for example, in period 2 elements, okay, it has a 2s and 2p orbitals. Okay, if they are all filled with 8 electrons, okay, the next available energy orbital is the 3s. If I were to exaggerate, 3s empty orbital is too high up in energy level for it to be able to fill it easily. Okay, so that's what it means. It has no vacant and energetically accessible orbital.